In this chapter, we're going to look at variables, constants, and calculations. We're going to look at pseudocode and flowcharts and introduce those topics to you. We're going to talk a little bit about memory in a computer, variables, a function called try parse, some math expressions, arithmetic expressions like plus, minus, multiplication, division, so on. Assigning a value to an existing variable. Also, a lot of your number data types have a toString method that allows us to be able to take a value and represent it as a string. There's also name statements that you'll need to put in your program, so that way it'll help you to debug your applications. And then we also talk about named constants. Now, whenever you start writing a program, quite often you've got to try to collect your thoughts. You got to try to figure out, okay, I need to do this first, I need to do that second, I need to do this third, and so on. Pseudocode and flowcharts helps with that process. Pseudocode, it's mostly just writing down comments and little notes on what you need to do. So for example, right here, if we're trying to write a program that's going to calculate the area of a circle, we'll write down some information here, maybe what the purpose of the program is, and then some stuff like, for example, the user needs to provide the radius of the circle, and then the application will calculate the area. And then we also need a button for ending the calculation. So we actually have a calculate button that will calculate the area, and then an exit button. So that's one way of doing it. Some people like, and so this is, so even though this is written out this way, you could expand the pseudocode a little bit more and write it like this, to where in the click button, you need to declare variables, you need to convert your radius string to a number, and then you can calculate the area and display the area in a certain area, in a label called label area. So a flow chart looks like this, to where you have a start, and then you have the different steps that you would need to use to complete each item, and then a stop. And so for your calculate click button, what would happen is that you need to first declare variables. You then need to convert the input text to a number, and then you calculate your area, and then you display the area in the label called label area. Then we also have another function, another thing that we need to worry about that deals with how to exit the application. We've pretty much, this is pretty easy. We just, there's a single command that we'll learn later on that tells us, okay, we need to stop the application from running. So yeah, so we'll move on to the next topic. Main area of a computer. The main area of a computer is called RAM, or random access memory. You can just think of this as a place to where you can store numbers and strings, things like that, and then be able to access them later. The book that we have thinks of it as a locker, to where you have a bunch of spaces through here, and you can put things in the different locations in the locker. Like for example, in our calculating the area of a circle, whenever the user enters in a radius, we can put that in a certain location in our locker. And it's just a coincidence that locker 10 contains the value 10. We could have actually used a different locker through here, like locker 1, to contain that value. And then whenever we're done calculating our radius, we'll have that stored in a different location, which in this case, we're storing that in location 12, and it has the value of 3.14159. Okay, moving right along, variables. A variable is just a memory location, like how we had here, this locker illustration. Each one of these locations here could be a different variable. In this example, radius is in locker number 10. The area variable is in this locker number 12. And so you just think of it as just a place to hold values. And that's all that really a variable is it's just, if you've taken math classes like algebra, it's the same thing as like having a variable X, a variable Y. It just contains a value that we will specify later. To create a variable, we have to use a dim statement, which tells us that, like for example, the best way to explain this, just look at an example, dim int quality as integer. What this does is it creates a integer variable that holds a value. Now an integer is just a whole number. In other words, it's like the number 1, 2, 3, 4. Anything without a decimal place, if it has a decimal place in it, like 3.4, that is a double in Visual Basic. A number like 3 or negative 10, 10, 20, 15, whatever, is an integer. So selecting the appropriate data type, a Boolean is a logical value. It can hold only two values, true or false. A decimal, it's a number with a decimal place. It has up to 29 digits. So look how big these numbers are. They're a really, really, really big number. And then double is a little bit smaller. It can hold up to 15 decimal significant digits. There's an integer. Those are the whole numbers I was talking about. And then string. That's just text. Okay. Selecting appropriate names. Your variables have to have names that describe what the variable holds. So like, for example, in our circle example, there was a variable called radius. Well, guess what? That's going to hold the radius of the circle. That's going to be a number value. Area, that was in the area variable. Well, that's going to hold the calculated variable area that we calculate from the radius. So for our different data types that we have here, a Boolean, how Visual Basic likes to do things. It likes to prefix a 3-digit letter or 3-digit code onto the front of our variables. So BLN represents a Boolean, DEC represents a decimal, DBL represents a double, INT for an integer, and STR for a string. So you can look at the first couple letters of a variable and know exactly what the data type is. The main ones that you're going to be working with are probably going to be the last three here. Well, probably all of them, but the most common ones are going to be string, integer, and double. Every once in a while, you may work with a Boolean if we have like a checkbox. But the vast majority of the time, it's going to be like an integer or string, maybe a double. So feel free on some of these quizzes to go through and try to answer some of these questions, and that'll help you to see if you really understand what I'm covering here. If you're getting several of these wrong, you may want to go through and read exactly what's going on here. Maybe watch the video a second time while you're reading, just to get a better idea of what's going on. Let's look at some examples. For example, the dim statement that we talked about before. Here's the basic syntax. What you see here in bold is exactly what you would type: dim space some variable name space as space some data type like integer, string, double, boolean, and you could set it equal to some initial value. Now, what you see here in the brackets here, that is optional. You don't have to specify a value there, but you can if you want to. So let's look at a few examples. Dim int quality as quantity, dim int quantity as integer. So this declares an integer variable called int quantity, and it sets it as an integer, and it is automatically initialized to 0. So if you don't specify an equals, it automatically initializes it to 0. In the second example here, dim int count as integer equals 1. So this declares an integer variable called int count and initializes it as to the value 1. Example 3. Dim bool is insured as boolean. This creates a boolean variable called bool is insured, and it automatically initializes it to false. The next one below will initialize the is valid to true, and the last example is a string, a message string, and it initializes it to nothing. Probably the empty string is what I'm guessing that is. Try parse. Now, whenever a user enters in data into a text box, it assumes it's a string. And that may be, if you enter in a number like 25, that's going to be a string. But we may be able to convert that to like an integer. Since 25 is an integer, we possibly could try to convert that to an integer. And so the way you can do that is each of the number types has a function called try parse that can take the string value, and it can try to parse that value. And if it's successful, it'll put it into this variable that's on the end. So double paid, it will take this paid string and will try to populate it there. If it cannot populate the value, if it cannot parse that string properly, it'll put a 0 there. So the same thing here for the total variable. It will take that value, and if it can convert it to a decimal, it'll put it in this variable called decimal total. If not, it'll store a 0 in that variable. Same thing here for the integer. It'll take the quantity that a person entered as a string and will try to convert it to an integer value. And if it can't, it stores it as a 0. So looking down here, here's several different examples. Here's the string that's being entered by the user. And this is what each of the different data types, the number of data types, would convert it to if you use that function on this string. So for the number 62, it converts this one to, for the double, 62 is a valid value for that. So is this for the decimal, and the integer 62. -9, each of them are -9, and 33, even with some space around it, the try parse is smart enough to look at that and convert it to 33. Now let's look down here at the number 12.55. The number 12.55, that's a string, but we know that it can't be an integer because it has a decimal point. It's really hard to see, but it's there. So out here in the integer part, it's going to put a 0 because it cannot convert that. All three of these are the same way. Since each of these has a decimal point, it cannot convert that properly, so it puts a 0 out here. Because there's less than 15 significant digits, it can do a double for 12.55 and convert that properly for all three of these. And the same thing here. These last ones here cannot be converted because you look here, $, what do you convert a $sign to? Here's a percent, what do you convert a percent to? In the third example here, it has an A. Well, an A isn't a number. And here there's a space between the 1 and 3. So it doesn't know how to convert that. And then if you have an empty string, which means that there's nothing there, it can't convert those either. So notice that none of these can be converted down here. Arithmetic expressions. These are just normal operators that you're used to seeing in mathematics. Now, Visual Basic does use some different symbols for a few of these, like the exponent. It uses the caret symbol, which is this little pointy arrow thing. What that means is that you would take a number and multiply it by itself that many times. So if you look down here in the examples, 7 to the second power is like 7 times 7 ends up being 49. So up here at the top, it tells you 7 to the second power is this, to the third would be 7 times 7 times 7. We have the minus sign for negation. We have multiplication, which is a star, and then the /, which is a division. Integer division, which means that you end up with an integer number. It means that you don't use the remainder. So that's a backward slash. Mod is a modulus, which gives you the remainder of some kind of division. And then you have your plus and minus for subtraction. And this one up here is negation. Means the reverse. So it'd be like -3, something like that. And it's the same operator that you see here as the subtraction. So here's some examples. The ones you need to be really comfortable with are the plus, minus, divide, and multiplication. The others probably could come in handy, but those are definitely the ones that you'll be using the most. Okay, and here's a few more examples if you want to look at those, but I assume that most of you are proficient in basic mathematics, so we'll just move along. Assigning a value to an existing variable. After you've declared a variable, remember the dim that we talked about a minute ago? If you want to assign a different value to a variable, it's as easy as specifying the name, putting an equal sign, and then the value. Now, the value you're assigning it to has to be the same type. So, for example, int year is an integer, so is the value here. 2019 is an integer. String city, that is a string variable. What you're assigning to it has to be a string, and we see that here. Same thing here. Dot text, it'll contain a string. Double rate is a double, and so whatever is signed out here has to be a number. Decimal rate, we can specify it this way. I won't really go into that much right now, but we could also do arithmetic. So instead of hard coding a value like what you see here, like with 2019 and so on, you could actually have another variable, multiply it by some value, or just have another variable and set it equal to a new variable. Now, most numeric variables also have a two string method. After we do some calculations or we have some number in a variable, sometimes we want to display the value of that variable. And the way to do that is to use a two-string method. So for example, if you have an integer in a variable called int age, in this example 23, and we want to assign a label that value, you can say int age.toString, and it knows to take the integer value, convert it to a string, put it in this variable or that property. If you just say label age.text equals int age, it's going to complain because int age is an integer and the label age.text is expecting a string. Same thing here. We can specify the type or the way that it's displayed. And the way it does it is the C2 tells it that it needs to be a dollar amount and to use 2 decimal places. And so it knows to display the data this way with the C2. That's what these format specifiers up here tells you. It displays the string with a $, includes 1,000 separation. In number, similar to currency, but does not include a $, and negative values are preceded with a minus sign. The F for fixed point, same as the number format, but does not include a 1,000 separator. And P for percent specifies the numeric variables value by multiplies the numeric variables value by 100 and formats the result with a % sign. So you can use these down here to format your numbers to make it look pretty. So instead of just like outputting 0.15, you can specify the format method and it will output 15%. Option statements. In your programs, you will want to specify option explicit on and option infer off. Now, the option explicit on, what it does is it tells the code editor to flag any undeclared variable. So it will complain and it'll say, hey, you have not declared these variables. You want that because you want to know if you are not declaring variables. You want to be able to know that so that way you can fix those issues. You can also enter in option infer off, and that tells the code editor Visual Studio that every variable needs to be declared with a data type. Now, if you leave those off, the compiler can be a little bit relaxed and will not give you some of the errors that you need to see. That's more for advanced programming or stuff like that. In this class, this is the beginning of we're just learning basic Visual Basic, the beginning stuff. So put these statements in there so that way it'll make your life easier, because if you are missing, if you're not declaring a variable or whatever, we need to know that. You need to know that so you can fix that. And lastly, we're going to talk about named constants. There's times in your program to where you'll want to use named constants. For example, the one I think about quite a bit is pi, 3.14159. Instead of hard coding all the way through your program this value for pi, you can create a constant and then use that constant throughout your program. And so the way to do that would be to use the word const space whatever your constant name is as, and you specify the data type and you set it equal to expression. So to do that for pi, we could write it like this. Const double pi as double equals 3.14159. If you've got a variable called max speed, you could write it like this. There's times that you'll want to maybe have a title, or there'll be a string that you'll use throughout the program. Let's say a name of a company, for example. And you're thinking, okay, instead of typing that name everywhere, you could create a variable with that company name. And then if something happens where the company gets bought out, you make a change in 1 or 2 places and your code still works. Here's an example of like a decimal rate. So like, for example, if you have a certain tax rate, for example, that you're using to maybe tax, or let's say, like, for example, like a tip tax or something like that. And then you want to make those adjustments. Instead of having to go through several places in your program and making changes, you can make a change in one location at the top of your program and not have to worry about going through and making those changes everywhere else. So that's about it. That's the content for Chapter 3. Feel free to read the reading assignment, this text that I've shown you, but what I'm giving you here is the highlights. If there's something that I kind of went over too fast or is not clear, watch the video again or go through and read these notes and look at some of the examples that they have, and maybe that will help you better understand what's going on. So I will see you next time.